Here's a fun one. Quick question. Does not need an answer. With all the different ways things form, such as coal from ancient trees decomposing before decomposing, what kind of other rocks could we find on other planets? I'm sure coal is much more rare than diamond since it can only be found on Earth, but some planets rain diamond. What kind of alien rock or crystal would you like to see? What kind of different formations are possible on other planets with different weather patterns, seismic activity, and potentially other forms of life? Okay, well there's an awful lot to actually break down with this. So, yes, stuff like coal, petroleum, and a lot of things those exist because we have the conditions for life on this planet, and because life has existed. Now, the thing about diamonds, there being diamonds raining on certain planets, it's believed that occurs on Uranus. There are diamonds on Uranus! And I think Neptune. And it's believed that basically what's happening is because these gas giants have such immense pressure, there's carbon and other things in the atmosphere on these planets, and that pressure is causing diamonds to form and literally rain on the planets. So that's really kind of That's really kind of a fascinating idea. It's believed to happen. It's believed that the conditions are there for it. I don't know that that's been exactly verified, but that is a popular belief at this time. So to answer, what kind of alien rock or crystal I'd like to see, that's really a fascinating question. Let's come back to that later. We need to take into account, looking at our own solar system, especially that the conditions for life are very exceptionally rare. We are in that exact prime spot where if we were moved slightly closer to the sun, further away from the sun, we would not have those ideal conditions for life to thrive on our planet. And those specific conditions give us such a wide variety of mineral wealth and formations that are likely seen in the vast majority of the rest of the galaxy, or universe, for that fact. And we'll get into that. So let's look at our own solar system first. Mercury, Venus, our own moon, and Mars specifically are mostly made up, as far as we can tell, of volcanic rock, so basalt, and things like plagioclase feldspars, as well as a lot of rare earth metals. There's been lithium and platinum and other things found on, say, Mars, for instance. Wide variety of mineral wealth. Pluto, for instance, is a lot of ice, but there is believed to be basalt, lava, and Pluto is no longer a planet, but will always be the biggest one in my heart. Let's look at the gas giants. While they may have some rocky cores and stuff like that, you're not typically going to see minerals forming on gas giants, and I don't even know that all of them have solid cores. I'm not too versed in that, but as far as I know, most of their mass is made from highly dense and compressed gases. So you're not going to see a lot of minerals on them per se. But let's talk about why Earth specifically has a wide variety of mineral wealth and why that might be something truly unique. So the vast majority of mineral deposition, or not, I shouldn't say the vast majority, but a very common form of mineral deposition on our planet comes from water. various minerals, things that form, the things that form crystals break down in aqueous solutions, and they're deposited in different ways. So, for instance, a geode from Mexico, per se. These volcanic geodes were vesicles. They're bubbles that formed in lava as the lava was cooling, and it left a cavity for crystals to line over time. Those crystals formed from mineral-rich liquids, hydrothermically, basically passing through this porous lava rock. And there comes a point when they stop being porous. But those form from water seeping into those geodes. The quartz from Arkansas, for instance, like the really nice Arkansas quartz, all of that forms from hydrothermal activity, where you have these hot mineral-rich liquids squirting through cracks in rock, and over time, the crystals kind of sort of fill in those cracks. So when you're out collecting, like say if you're doing hard digging in Arkansas and you're chasing a quartz vein, what you're doing is you might be looking at, say, a rock wall. Now this isn't always the case, a lot of people do tailings diggings and stuff like that. But say you're doing some old-fashioned digging, you're looking at a rock wall, and you're looking at these veins of quartz in various places all over that, and what you'll start doing is start breaking into that quartz and chasing that, hoping that it's going to open up into a cavity with bigger crystals. Okay, fine, fun, dandy. But the fact that we have so much aqueous solutions, that so many minerals form in this way, it does create a very different circumstance for minerals to form than a lot of places. You're not going to probably see big quartz crystals like you see on Earth on other planets. Now, what can form on other planets, let's talk about asteroids, for instance. One of the niftiest minerals that we have ever found came from an asteroid. It was discovered in the late 1800s in Arizona, and it's called moissanite. And today it's mostly lab grown, but it's considered a diamond substitute. It's the crystalline form of silicon carbide. It was first discovered in meteorites. The conditions for that silicon carbide to form on Earth are so uncommon, it just really doesn't happen. So there are things that would not form as easily on Earth that do form in other places. Form in asteroids and form on other planets. There's a lot of mineral wealth out there. I vaguely remember something about like an asteroid, like a golden asteroid somewhere that was believed to have a ridiculous amount of platinum and other stuff in it. That was caught in a field between Mars and Jupiter, I think. That'd be kind of cool. So what would I actually like to see? I would love like a nice piece of natural moissanite. That would be really, really cool. I think that's probably my answer to what I would want to see from like other planets or from outer space in general. But really, this is a complex question that I don't have the best answer to. Mostly because there is so little that we know. So how do we know what kind of minerals are on some of these planets? Well, with Mars, we've been able to take some samples from Mars rovers and stuff like that. In a lot of cases, they're using basically refraction and testing wavelengths of light that come back from planets, and by doing that, scientists can kind of tell what minerals are there based on what wavelengths come back, because all minerals give off basically reflect back wavelengths of light when you're looking at them. I'm not super versed on that, so I shouldn't speak too much on it, but that's kind of the idea, is they look at the light that comes back and they can determine based on the wavelength of light coming back what minerals are present. And they can do that way out in space as far as I'm aware. But we do know a surprising little, just the sheer expanse of the universe is mind-boggling, and there's so little we actually know. It's easy to think in our current day of technology that we know so much, but we really know so little. I couldn't even begin to guess what kind of minerals that we've never even seen before, what kind of elements that we've never even seen. Even elements, yeah, I assume that there's probably elements we've never seen before out in the far reaches of the universe. It's amazing to think about, and I couldn't even begin to wonder. This is a fantastic question, but there's just too much we don't know. There's just too much we don't know. It's fun though. But anyway, I hope you all enjoyed this. If you haven't yet, please consider liking, subscribing, hitting that little notification bell, leaving a comment. YouTube's being a little funky with the algorithm lately, and I could really use your help. If you watched this far, thank you. If you liked the video, I would appreciate it. If you didn't, thanks for watching this far. I still appreciate it.